Today we have Carl Cressey with us with Halton Company to discuss airflow solutions for food halls. He's a veteran in this industry and has been with Halton for the past 20 years. So he's going to be the guru when it comes to kitchen ventilation systems and improving indoor environments. So thanks again, and I'm going to go ahead and pass it off to Carl.
Thanks, Alex. Thanks everyone for taking the time out today to join us. First of all, I hope everyone is safe and healthy in these unprecedented times. Today we've put together a presentation on adaptive hood systems specifically for food halls. A new segment piece that we put together. We've done quite a few food halls over the last 10 years and just wanted to take a few minutes and share some of our experience with you guys on these. So I just wanted to touch off with a very brief history of Halton, but we're a family-owned company, started back in 1969 outside of Helsinki. We're a Finnish company and still family-owned. Mika Haltunen and his wife, Tarja, are engineers by trade. We have several different operating divisions that we look to globally. We are in the food service division, and specific to food service, we operate in 39 countries and have 14 manufacturing facilities through company-owned and licensing manufacturing facilities globally at this point in time. This slide just shows some of the solutions we have within our food service scope. We're not going to talk about all of these today, but everything that we do is based on improving indoor environments for demanding conditions. So food service certainly fits in that arena, and we look to improve indoor environmental quality, energy efficiency, and safety within a given environment. So we'll touch on several of these solutions today, but certainly not all of them. For food halls, there are a couple key things that we need to consider. Facility infrastructure is one of them. We have food halls going into, application buildings that weren't necessarily purposed for that originally. So we have to work around the logistics of that. Mitigation of risk. We'll talk about that in detail. Vendor operational flexibility is probably one of the key components we need to look at, because we have to design for an unknown in many cases, with vendors coming on board at all times. And then finally, comfort and efficiency, which are some key differentiators for Halton. So as far as the infrastructure flexibility, we're with food halls specifically, we have to develop these systems many times, not knowing what's going to happen in those tenant spaces. So flexibility is key. We need to understand what the filtration needs going to be at the hood level or at the discharge level, whether pollution control might be a concern. We'll be involved with the design early on from a comfort and energy efficiency standpoint. Risk mitigation will be important as we look to grease deposition at the hoods, as well as odor management at the discharge. And the vendor and developer scope of responsibility are also key when working on these types of projects. We typically will get involved early on with the mechanical and food service design teams and the developer in working on the scope of the project. The vendor operational flexibility is also a very big part of this. As we said, these types of projects are changing on a pretty regular basis. One of the ones we worked on a couple of years ago was an incubator concept, where the one guaranteed thing was that every couple of years they were going to turn their tenants over. So they were bringing in new operators to help develop concepts, help them get their name built in the area, and then they were going to bring someone else in. So we need to design a system that can be adjustable as new tenants come in, and operating independently with the other tenants in that space. So we have systems that allow us to potentially tie exhaust and supply systems together, even if we have multiple tenants on the same exhaust or supply platform. So, and certainly a big part of this on the energy side is the ability to monitor and report what's going on in terms of an energy use standpoint for a given operator. Mitigation of risk is certainly a big component of this. When we have multiple tenants sharing a common system, one of the things that we'll look at and monitor is grease deposition in the ductwork. At each location, you're going to have different tenants that are producing different amounts of grease and odor that we need to look at maintaining and mitigating some of the odor and fire risk. We have some different options that we'll get into a little bit later in terms of pollution control, but once again, designing for flexibility is very key, and tying in some of the mitigation components of that are very important as we tend to change operators over time. Just a couple of slides as we get into the system design. We have a couple of different platforms here. The control system is really kind of what ties everything together. So we'll talk a little bit about our controls platform, which is called M.A.R.V.E.L, and our web-based monitoring Internet of Things platform, if you will. The base building requirements that we need to consider early on in terms of the overall number of vendors that will be in the space. We've worked on systems that have had 4 or 5 vendors in a given area. We're working on halls right now that have up to 50 different vendors. So these are very critical concerns when we're looking at and designing a system. And then the vendor space, the vendor components, which typically are the hood and the controls platform tied in at each individual location. Halton Connect is our monitoring system. So when we have these types of systems, we're able to monitor and observe what's going on at the overall system as well as each independent hood. These are secure networks. They're third-party audited. We have a network center in Dallas where we're able to create specific reports for the developer and individual tenants. We can actually sub-meter utilities going into both exhaust and supply systems and individually at each tenant location, and provide monthly reporting back to the developer if they want to bill energy out accordingly. Obviously, that would be based on the tenant lease agreements, but there's some very unique capabilities that we have with this. One thing it allows us to do, a very important aspect of it, is remote access to the systems also. If we do ever have any trouble on a given application, we can dial into that system and make changes from a remote location and potentially address some problems, or at least put a system in an override until we can actually get a service tech on site. This slide just shows the architecture of the system, but we have the kind of the local automation on board at the hoods. We have the controller, we have the gateway, and then we have a machine-to-machine communication protocol. We're storing all the information in the cloud, and we'll monitor and build the dashboards at our network center in Dallas, and we'll tie that in specifically to Halton's service network. And we have a couple of different platforms that we're able to offer there in terms of letting operators know when potential service issues may arise, or even dispatching service remotely as required. So M.A.R.V.E.L is the brains of the system, the controls, if you will. And what M.A.R.V.E.L stands for is Model-Based Automatic Regulation of Ventilation Exhaust Levels. It's an integrated control platform that allows us to monitor and modulate what's going on at the exhaust and supply levels, as well as each independent tenant location via the use of dampers with actuators and VAV terminals, variable air volume terminals for the makeup air side. So this graphic shows that we have the ability to even zone those airflows based on the requirements of the space. So this particular graphic shows 3 different zones, and we're tied into one exhaust and one supply system on those 3 zones, and monitoring and sending that air where it needs to go. So it's a very flexible system, once again, that allows us to change over time as those vendor components change. So this slide talks briefly about kind of the components that are involved in the M.A.R.V.E.L system, but it's a very smart hood system, if you will, in that it uses controllers on board at each hood, as well as a master PLC. We have pressure transducers on board at each hood also. That's a very key component because that is what allows us to measure the airflow at each hood. We do calibrate these hoods through laminar flow elements, so we know at a very specific static pressure how much air is being exhausted through that hood. We have dampers, UL listed approved dampers at each hood also that allows us to modulate both the damper position as well as the fan speed for that individual hood and maintain either an off, full on, or idle condition at that hood based on what's going on under that hood. We utilize infrared index cooking sensors to detect cooking activity under the canopy. And the infrared sensors are sighted to the actual cooking equipment, and we're looking for temperature fluctuations. So temperatures up or down. An example I use on a pretty regular basis is if you drop a basket of frozen fries into hot oil, that surface temperature actually goes down before it starts to increase. So we see that temperature reduction at the cook surface, and we understand that we've just dropped cold product, and we tell the fan to speed up at that point. So the other types of systems that are out there typically rely on some type of temperature device in the ductwork to read that increase. So in a very drastic case, it could be upwards of 3 minutes before that temperature sensor would see an increase in temperature. So this infrared index sensor allows us to act immediately based on what's going on at the actual cook surface. The big part of the vendor package for food halls is the hood. Our hood is called Capture Jet. It's a high efficiency hood that allows us to exhaust typically about 25 to 30% less air than a standard canopy hood. It utilizes a patented jet technology that takes a very small amount of room air and induces it through a plenum at the perimeter of the hood. It allows us to, via a low pressure or an induction effect at the front of the hood, reduce the exhaust volumes by 25 to 30%, and in turn, reduce our supply volume. So when we think about the energy for a typical hood system, the fan energy is a part of that, but the bigger part of it comes from the reduction in HVAC on the mechanical side. So if we're able to reduce air in the exhaust side, we can reduce tonnage on the HVAC, fan size, ductwork, and the associated energy that goes along with running that system. So Capture Jet is here's just a quick video of two hoods side by side. The hood on the right is actually a Capture Jet hood, and we have those jets turned on. The hood on the left is a standard exhaust hood. So what we're seeing here is here at the front of this hood, you can see convective heat spilling into that space. So what this is called a Schlerin thermal image. It's a photo process that allows us to visualize changes in air density. So we're looking at convective heat here. There's no cooking being done. There's no smoke being generated in this image. So once again, this is what causes that temperature in that kitchen to increase. This is carrying that submicron grease, that respirable particulate that's tending to coat the ceiling tiles and the stainless surfaces. Here we have the ability to, with a higher efficiency hood, to do a better job of capturing and containing and keeping that heat within the hood. This hood can do the same amount of work, but without the perimeter jet system that allows us to lower that airflow. We would have to increase airflows on the exhaust plenum to create a greater suction pressure to achieve those same results. So the vendor package, you would typically have the hood itself. You would have the M.A.R.V.E.L controller. There would typically be one for each vendor. And then there would be a master PLC for all the hoods tied to a specific system. And the fire suppression would be another consideration, especially if we are looking to design for flexibility. So we could certainly design for an overlapping type of system that allows us the greatest flexibility in terms of moving appliances in and out over time and changing that equipment layout. In terms of the base building design, we would work pretty early on with the design team in determining, what are the real requirements of the project. If we need perhaps a pollution control unit, if there are adjacent spaces, or this is perhaps in a commercial, residential, or a mixed development use, we would certainly look to a pollution control unit for designing a system that's going to do a good job of capturing grease, smoke, and odor, so we don't have any nuisance odors for nearby tenants. Or if not, we could look to a standard upblast exhaust fan. This particular fan is a fan we use for a lot of different applications, but it's a stainless steel utility blower with a grease containment system that can either be collected in the base of the fan, or we can actually pipe it back down to the hood itself. This particular fan, we have the ability to design up to about 10,000 CFM, and we'll get very stable performance with this fan up to about 4 inches of static pressure. In terms of pollution control units, these are modular units that would take the place of the exhaust fan. You do actually have a built-in blower section on these units. They could be interior to the space as an inline system. They can sit outside on the roof or on a pad, but they're going to incorporate some type of filtration, either filter media, M.A.R.V.E.L 14 and 18 filter media, or electrostatic grease collection. There will be some type of odor mitigation built into this unit. We utilize UV light and carbon panels. Here is a section of UV light with 2 carbon sections here. This is a double pass electrostatic section here. So we're collecting the grease in the first module, addressing the odor in the second module, and then the exhaust module will be the last. And this is a modular unit. These can be split up if needed. Once the CFM, the exhaust requirements of the system, are set, the width and the height of the unit don't change, but as we add features, the length of the unit can certainly tend to grow. So as far as the mitigation of fire, we have a couple of different solutions that we would typically look to for food halls. We have grease sensors that we install at the hoods themselves. So we would look to a high efficiency filter in the hood, perhaps even a continuous mist section or ultraviolet light in the hood for grease destruction, depending on the application. But we have a grease sensing system that we would mount in the hood collar that identifies quantifiable buildup of grease at each individual hood as well as the main trunk, and tells us that as that grease builds up, we need to clean our ductwork. So it's a system that's calibrated to NFPA 96 cleaning requirements for ductwork, and it would send an alarm to the panel to alert when the ductwork's been needs to be cleaned, or that it perhaps it was cleaned and maybe it wasn't cleaned properly. So just once again, a mitigation device that allows us to measure what's going on. So these would be some of the key components that we would look to for a food hall application. Obviously, the hood's a very integral part. Ductless ventilation, for some food hall applications where we don't have the ability to exhaust to the exterior, we have a couple of different platforms that we can look to there. This particular unit is a completely self-contained cart that comes complete with all your pollution control units, fire suppression, cooking appliances, everything you would need to roll that cart in and just start cooking in a given space. The pollution control units and exhaust fans, as we've just discussed. air handling units, every cubic foot of air that we take out of that building has to be brought back in. So, we have supply units where we could provide for makeup air. These units are typically in colder climates. They might be tempered to 60 degrees in Florida. Certain locales might use tempered heated units, but most of the units we would definitely look to in Florida are going to have some type of cooling included. Duct safety systems as well as energy M.A.R.V.E.L control systems are very big parts of the system also. One of the big parts of working on the food halls is start getting in early on the project, working with the developers and the engineering and design teams to really understand what the scope of the project is, what solutions will be required, and then designing a system that is going to meet the flexibility of that requirement. Once these projects are designed and equipment has been ordered, we have a nationwide service network that provides both pre-site visits as well as commissioning visits and care visits. We actually will come back out after the project has been in operation for several months to work with the owners, the people that aren't there typically during that turnover, and retrain them on the system. And then also with the Halton Service Network, we have the ability to offer preventative maintenance and monitoring and service packages for these types of locations, depending on the solutions that are chosen. So we'll be an integral part of the project from the inception to the completion, and for years to come. These types of projects aren't ones that we can typically just work on for a couple of months, sell some equipment, and then walk away from. The success of these projects is based on integration from early on. We do get involved. Alex with Eaton is their ventilation specialist in Florida. He will be involved in all these projects from a very early standpoint, and we will stick through them for years to come. This is it's part of what Halton does, and we've been doing it for over 50 years, and aren't planning on changing our approach. But as the engineered system on the market, these types of services are very important to ensuring that these projects are going to go smoothly. So, guys, they told me I had about 30 minutes, so that is our presentation for today. It's a lot to cover in a pretty short time, but we do have a white paper on food halls if anyone would like to take a look at that. You can download it at foodhallkitchenventilation.com. I've also included both my email and my phone number. I do make it down to Florida on a pretty regular basis to work with the Eaton team, and would be happy to help out in any way possible. So, Alex, that's what I have.
Awesome. Well, yeah, we really appreciate it. That was awesome. Do we have any questions for Carl before we close out? All right. Well, we really appreciate everybody coming out. Come back tomorrow, and we have PJ from RPI Holdings speaking tomorrow. So come back to hear from him. So thanks, everybody, and have a great day.
All right. Thank you very much. Appreciate everyone's time. Stay safe.